Hello, my friends. I wanted to make you a little video to help you study for the interim assessment test, interim assessment 1. It's a big test, and I know sometimes it's nice just to go through the study guide and get answers. So I thought I'd make you a video where you could do that and get the information you needed so you could score beautifully on your interim assessment 1. Keep in mind that until you complete test 1.05 and test 2.07, you cannot take interim assessment 1. Now, for those of you who started the class with me in the first 3 weeks of school, that means you have to complete quiz 1.03 to get to test 1.05 and quiz 2.04 to get to test 2.07. So please make sure you've been keeping up with your work. If you're lost or confused, please let me know. All right, so we're going to get started. I just want to bring up a little information here about our good friend Wilhelm Wundt, Mr. Turn down for Wundt, if you will. And the thing that I want to point out, and it got cut off a little bit by the slide, sorry, is that he is best remembered for adding the scientific method to psychology. Remember, before he comes along, psychology is what we call a pseudoscience. It's really not something that can be proved by science, and it was kind of considered fake or false. But when he starts adding in this scientific method, people begin to see, hey, there is something to what they're talking about. And of course, he's also remembered for creating structuralism, which we know is about introspection, looking inside yourself to understand how you respond to sensations before the sensation, during the sensation, after the sensation. But the problem was no two people respond to sensations alike, and the truth is everybody's different. So in this case, there was no way to get a central tendency, meaning the majority of people did the same thing, and so it was declared too subjective, and it's not used much anymore. A little bit, but not much. So let's talk about the different approaches and how each of them would have been used. I may go a little bit out of order from the study guide, my apologies, but I will hit all of these items. The first one I want to talk about is neurobiological. And neurobiological, anytime we see the word neuro, we think, oh, brain. Brain. So of course we think brain, neuro is brain, biology, all that stuff going on inside of us. And so we know that our genetics, our physiology of our brain, our hormones, our chemistry, all that good stuff going on inside of us, how does that affect our personality? That's what neurobiology is looking into. And very often the treatments in neurobiology involve medication or some form of therapy that would address the biological needs. All right, I use this slide to mention evolutionary psychology right here. And evolutionary psychology grew from the concept of functional psychology, which was influenced by Mr. Charles Darwin. And it says that the natural selection of traits, how our natural selection of traits influence behavior. For example, most people are not very comfortable being out at night. They prefer to be out during the day. Central tendency indicates to us that this is how most people respond. And you might look at evolutionary psychology and say, oh, well, we probably respond that way because at night we don't have very good vision and we don't have the same ability to smell our prey, and so we'd be easier to kill at night if you go all the way back to our caveman days, right? So how does that natural selection of traits influence us? It's often used with criminals and criminal mindsets, kind of looking at how a person became a criminal. What was their genetic background? What was their family background? What was their environment? What could have led them to where they are now? Oh, okay. So there's evolutionary here, biology, neurobiological, same thing, behavioral. My good friend, behavioral psychology. You know how I love that one. And I'm sitting on this Death Notes dude's picture, so I know some of you are fans of that. I'll let you enjoy him. Behavioral looks at our learning process. And you know from Unit 3, that's what we're talking about, long-term change in behavior over time. And it focuses on both the influence of rewards and punishments, but also connecting our voluntary or involuntary responses to changing them or adapting them to something new. And so the thing to know about behavioral, what you really need to think about is that this is how we respond to the environment. It's all external. Hashtag outside only, as someone said. It's all about our responses and what I can see you doing. If I'm a behaviorist, I don't want to know what's going on inside your brain. I don't want to know what your emotions are. I want to know what can I see you doing. If I can see you doing it, then I can observe it and I can decide, is this a behavior that helps you? Is it a behavior that should be changed? And we've talked about classical and operant conditioning and social cognitive theory are the three major approaches of behaviorism. All right, cognitive psychology. This has to do with thinking. It has to do with the mental processes that we use to acquire knowledge, store and use knowledge, and how our thoughts and our feelings can kind of cloud our perceptions or change our perceptions. I mean, think about it. If you walk into a room and you're wearing your favorite top and you feel good about yourself, chances are you're going to look around the room and you're going to see a lot of positive things. If you walk into a room and you're wearing something you really hate because your mom told you that you had no choice but to put it on and it's not what you wanted to wear, you're probably going to walk into the room going, well, look at all of these negative things around me, right? So our thoughts and emotions can really change our perceptions, but we also need to know where a person is in their mental development. Like I've said before, I can't expect a kindergartner to give me the kinds of answers that I might ask from my high school students because their mental development is in no way as deep as yours is. So we'll talk about that more in Unit 4, but it's important to know how that works, and I'll move myself over here and talk about humanistic. Humanistic psychology, it's all about personal growth. It's all about the idea that you can take control of your life. The idea that your past is not of importance. Okay? You can take control of your life. You can say, this is where I want to go. I'm going to put all of that aside, put my past and everything aside, and decide how I'm going to get from point A to point B. Okay, so you're in control of your life in humanism. The ultimate thing for you is to grow and develop until you have complete and total knowledge of yourself, which is self-actualization, the complete and total knowledge of yourself. Remember, it's not perfection. Nobody's perfect. We're all human. But it is the best knowledge of yourself, and that's what you want to clue into there. All right, a couple more. Psychodynamic, also known as psychoanalysis. Why it has two names, as I've said before, still not sure on that one. But basically, the idea is that we have things in our unconscious that can collide with cultural norms, or they can cause us to behave in certain ways that we may not even realize that we're doing. Like, for example, what kind of pushes you to look for something that's pleasurable? Like your mom says you have to go to school and you're like, but I want to go play a video game. Like, but you know you need to go to school and you know you need to get that education, but you want to play the video game. Why? What's pushing you towards that video game, even though you know that's really not what you should be doing right now? Okay, and I know you're probably like, it's fun, but according to Freud, that would be something called your id, which is always looking to have fun and never interested in thinking about the future. And and excuse me, let me go back here one more for psychoanalytic or psychodynamic. Your childhood is a big one for Freud to go back to. What happened in your childhood? What maybe you had a bad experience at school? Maybe that's why you don't want to go to school. And then last but not least, sociocultural, also called sociological. And as I mentioned, I'm not going to get into that because of a whole other wonderful class Miss Solomon teaches. But basically, it has to do with how social actions and culture, how personality, all of these things come together and influence who you are. So we're all influenced by the media, whether it's what we want to drive or who we want to be or what we want our body shape to be or what clothing we want to wear. We can probably find something that influences us. It could be our religion, it could be social media, it could be TV. Any number of things can drive us. And so how does this affect who we are and how we see ourselves? That's what sociology is kind of looking at. All right, questions 2 and 3. We want to be able to know about the variables in experiments, and we want to think about why we would use certain types of research. So number 2 asks about the various variables, and number 3 asks about using an experiment versus a study and validity. So let's talk about experiments. All right. Why am I going to use an experiment? Well, we know it's because I want to find cause and effect. I want to know if changing this variable causes an effect on this person or this variable. That's the reason I use an experiment. I'm showing direct causation. Okay, and the parts of an experiment include the independent variable, which is the variable that, as the scientist, I would manipulate to cause an effect. Okay, so in the marshmallow study, do you remember where the little kids were told you can have one marshmallow now, but if I come back in the room and you haven't eaten your marshmallow, I'll give you two later? They were testing delayed gratification. So they were testing, would kids be able to be willing to delay their gratification knowing that they could get more later. So whether I give you one marshmallow now or two later, that's what I'm manipulating. The dependent variable is the variable that experiences the effect because it's dependent upon the independent variable. So if the kids would be the dependent variable. Do I eat my one marshmallow now or do I wait for two? Well, two is more than one, but the question is, at what age is a child able to actually do that? So that's kind of what they're looking at. An extraneous variable is a variable that might affect the experiment and needs to be controlled. So for example, the temperature in the room. If it's really cold, the kids might feel sleepy, they might feel sluggish, or if it's really hot, they might be hyper and excited and they may not be able to control themselves as much. So I need to think about things like the temperature in the room. Am I giving them chairs that are super comfortable, super uncomfortable, things like that? And the confounding variable is the variable that affects the experiment. It could be one I tried to control, but it could be something that affects my experiment that I didn't even think about. You know, for example, let's say I have a room that's relatively comfortable. I mean, just standard chairs and the temperature's a nice temperature. But then let's say that this experiment was actually done in the basement of a church, for real. And let's just say that someone on the other side of the basement decides to bake chocolate chip cookies. And that smell comes down the hall and the kids, oh, chocolate chip cookies. And maybe they can't control themselves as well as they could have if there hadn't been the chocolate chip cookie smell. So that could be a confounding variable. It's going to affect my experiment. There's not much I can do about it. All right, and the difference between an experiment and a study. Why would I use an experiment? Why would I use a study? A study helps me to understand relationships. Why are that there's a link between variables. It doesn't necessarily tell me what the link is or how one affects the other because it doesn't show that one thing causes another. A good example is when we talked about when the sale of sunglasses rises, the sale of ice cream rises. Well, we know buying sunglasses does not cause you to buy ice cream, but we know there's got to be a relationship, and we mentioned that it's probably the heat and summer, right? So with the survey, I can see if there's some kind of relationship between the two. And it's important to talk a little bit about validity, and I seem to have forgotten a slide on that. I'm very sorry. I'll try to get that for you. But validity has to do with, did the experiment measure what it claimed to measure? So let's go back to the marshmallow experiment. They claimed that they were measuring self-gratification, at what age children can show self-gratification. If they started measuring if boys are taller than girls, that's not what they said they were going to measure. So my theory or my experiment becomes invalid because I'm not measuring what I said I would. I'm not actually testing the hypothesis I said I would test, and therefore I can't trust those results, so it's invalid. So validity has to do with, did I actually measure what I said I would measure? All right, rocking and rolling, questions 4 and 5. Let's talk about the function of the sympathetic and parasympathetic nervous system and the parts included in the central nervous system. All right, the sympathetic and parasympathetic systems are in the autonomic nervous system. This is an involuntary system. It's one we can't really control. We can eventually get control of our reactions, but there's that split second where it's going to kick in and we can't necessarily control it. A sympathetic is fight or flight. So let's imagine that your teacher says to you, hey, I want you to get up in front of the whole school and give a speech. At that moment, the first thing that's going to happen is your stomach might jump a little bit. Your hands might feel a little bit sweaty or tingly. You might, in the back of your mind, kind of freeze, or maybe you kind of blink, or maybe you're thinking, okay, wait a minute, what can I talk about? That's your sympathetic system. It's gearing you up to either fight or flee or freeze. Okay, these are the three options. Fight would mean that you say, okay, what do you want the speech to be about? What do I need to do? And you go through. Okay, it doesn't mean that you necessarily stand up and, come on, teacher, let's go. It means that you rise to that challenge. Flight meaning you're like, I can't speak to people. No, I don't do that. So sorry, I gotta go. My mom's calling me. So you try to get out of there. Flee mean or freeze, you're just kind of like, so your sympathetic system's going to kick in. Once that system kicks in, you need the next system, which is the parasympathetic system. After your sympathetic system kicks in, you want your parasympathetic system to kick in, and this is what we call our rest or digest nervous system. This is the one that helps us come back to what's called homeostasis. It's where we kind of come back down, we kind of relax, we calm ourselves down. It's also the system that controls digestion. So, when you've eaten like a big meal or everyone likes to joke about eating turkey and how it makes you sleepy. It does because of tryptophan. This is the part that causes your body to sort of shut down as you digest. Okay, so this is the job of your parasympathetic system. So it might be like, whoa, calm down. Deep breath. Okay, we can figure this out. That's kind of your parasympathetic system. And then the central nervous system, let me move myself over here. That is two parts, your brain and your spinal cord. And if you look, it's in the center of your body. I mean, not if you consider your body up and down, but if you consider your body left and right here, it is from the top down. So that is your sympathetic, or your central nervous system. Sorry about that. Your brain and your spinal cord. All right, number 6, transduction in the brain, the senses that are affected and the sense that does not go through transduction. Transduction is, hang on a second, I'm trying to figure out how to move myself around here. All right, I need this here. Transduction is the process of changing sensory information into electrical impulses. So the idea is that our brain runs on electricity. Remember I sang for you, it's electric, boogie, woogie, woogie. Yes, I actually sang again. So sorry. But when you think about your brain being electric, it can't accept information that is not electric. So that information from your eyes, your ears, your mouth, and your fingers has to come to your brain and be changed so your brain can receive it. And that's what transduction is. But as we know, smell is the only sense that does not have to go through transduction. I mean, think about it. Smell is a gas, right? So it doesn't go through, it goes straight to your olfactory bulb, and your olfactory bulb sends it immediately here to your limbic system and your thalamus and hypothalamus for translation. And that's why it's most closely linked to memory, because it has the least processing time. All right, what happens during REM sleep? What is paradoxical sleep? And what can happen if a person is deprived of sleep? Well, REM sleep, as we know, it's the last stage of sleep. It's the deepest stage, and it's when our brains are super active. We're dreaming. Our eyes are moving all over the place because it's rapid eye movement. Eyes are closed, but our eyes are moving all underneath our eyelids. I don't know if you can see there, but here we are dreaming, like, for example, that we're Superman or Supergirl, and we're going to jump off of a building and fly away. How come we're not moving? Well, that's what paradoxical sleep is. Paradoxical sleep means our bodies are paralyzed. So our brains are super active, but our bodies cannot move. And we do that to protect ourselves so we don't actually try to jump off of the building, which, as we know, would probably be a bad idea. And so the question becomes, why do we sleep? I mean, the truth is, we spend 1/3 of our lives sleeping. And we know that if a person remains awake for several days, their immune function drops, their concentration deteriorates, there's more accidents. I mean, look at this list over here of things that can happen. But why do we sleep, as we remember? We're still working on that. We haven't found a theory that totally explains all the parts of sleep. But we do know that without sleep, we could have impaired concentration, emotional irritability, even fatigue and death can occur. I mean, you have to not sleep at all for like I think it's up to a week, maybe it depends on the person. But in general, if you find that you're constantly fatigued or you're having issues with trying to understand or focus on class, maybe you need to go to sleep earlier. Maybe that's what's going on for you is a little bit of sleep deprivation. Selective attentiveness. Oh, this was fun with the inattentive blindness and change blindness. Remember our monkeys? Remember our the experiment here? I'm going to put this over here so you can see the selective attention. As we remember, our brains cannot process every sensory piece of information that comes at us. I mean, there's so much to deal with. So our brain is trying to kind of select what are we going to pay attention to. And inattentional blindness refers to the inability to see an object or person in our midst. So, for example, we watched this video where the gorilla walked through the screen and most people saw him, but some people were like, wait, what? There was a gorilla there? Because they were so focused on trying to count the number of times the people in white shirts passed the ball. So inattentional blindness, for example, you might be playing a video game and your mom might be standing behind you and you turn around, all of a sudden you're like, whoa, mom, when'd you come in? You didn't know because of an intentional blindness. Change blindness is very similar. It is a form of unintentional blindness where you fail to notice a change in your surroundings. So, for example, one of the examples I was using is I was working on a lesson plan one day and I was just really working on it and, getting just the right memes because, I'm amazing with memes. I'm just kidding. And putting together the PowerPoint and just making it like perfect. And my daughter, when I started, one of my daughters was sitting there in the room. And so I said to my daughter, hey, honey, I need you to go get blah, blah, blah for me. She didn't respond. Type, 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 type. Hey, honey, I need you to go. Hey, honey, I'm talking to you. Type, type, type. I look up. I was the only person in the room. When did she leave? That would be change blindness. My environment changed, but I didn't notice it. All right, the functions and parts of the brain. And what could happen if each one was damaged. I'm going to start here with the cerebellum because that's one we didn't really talk about, but it's a good one to know. This is the back part of the brain that controls your coordination and muscle movements. Raise your hand, wave at me, pat the back of your head. That was your cerebellum, all at work there, helping you with your coordination and your muscle movements. Now, the decision to raise your hand and wave was your frontal lobe, because it's the one that controls our personality and it controls voluntary movements. But your cerebellum is the one who coordinates things like a sneeze. It's not like you stop and you go, okay, first I'm going to inhale, then I'm going to expel air through my nose. No, your cerebellum's the one who controls things like that. If it's damaged, you might have trouble with anything that involves coordination, walking, waving your hand, clicking your mouse, writing, anything like that. So let's talk about our friend, the corpus callosum. We love the corpus callosum. It keeps the left and right hemispheres of our brains together and allows them to communicate. And our brains are in constant communication. You're thinking to yourself, ooh, I'm going to say this would be really funny, but I need to make sure I use this word and not that word. That was like your right brain's going, ooh, this will be funny. And your left hemisphere is going, yeah, but make sure you use this word. So the corpus callosum lets it travel back and forth. And then our lobes, the lobes of our brain. The frontal lobe, as I mentioned, this has to do with voluntary motor function, but also personality, mood, recalling things. This is all frontal lobe jobs. Our temporal lobes, which are down here by our ears, they have to do with hearing. What can we hear? Our auditory ability. They are involved in things like the formation and management of memory, insofar as you're getting that information from your ears into your hippocampus. You have your occipital lobe, which I always love that my occipital lobe is back here, and of course my eyes are like the opposite. You know, it's like, why does it have to travel that far? I wonder if that's why sometimes you see something, but it takes you a minute to figure out what you're seeing or doing, because it just takes that information a while to go back from your brain to your occipital lobe. I don't know. But it has to do with vision and being able to kind of see the whole of something. And then last but not least, your parietal lobe, which tells you that, you know, if you like a particular food because it's soft or crunchy, the parietal lobe's the one that interprets those sensations. And if you're ever having trouble concentrating, just reach up here, right kind of top of your head, and rub your parietal lobe and say, please help me, I need to concentrate. And of course, these folded thingies are called convolutions, all these little pieces, and we know that they help us with the storage space in our brain. We would not be as smart as we are if we had smooth brains. The hypothalamus. Are you cold? Are you hot? Are you comfortable? Are you thirsty? Are you hungry? These all come from hormones that the hypothalamus ever so thoughtfully creates for us to let us know. And any information that comes from the spinal cord to your brain or from sensations that need to go out to different parts of your body, that is your thalamus. It's like your mailbox. It's processing information, it's bringing it in, it's sending, or post office, I should say, sending it out. It does not receive information from the olfactory bulb in the same way, though, as we mentioned. And our hippocampus, which is not a college for hippopotami, although that could be a lot of fun to go to. It helps us to convert our short-term memories into long-term memories. All right, question 11. Know the two theories of color vision and what each explains: opponent process theory and trichromatic theory. Ever so much fun. Let's start with trichromatic theory, actually, which I know I'm like backwards. It has a nice long name, the Young-Helmholtz trichromatic theory, also called the rod and cone firing theory. This is a pretty simple way of looking at color vision, because the truth is we still aren't 100% sure how color vision works, but these are our two leading theories. It basically says you have three types of cones. You have red, blue, and green. And everything is made up of some combination of these colors. So if I see a lot of red, it's going to be a different color than if I see a lot of blue. But all three of these colors, which our little pencils are so thoughtfully drawing for you over here, will be combined to make any color on the planet. The problem with this is it's a really simple theory that we combine we combine these colors in different ratios to make new colors, but it doesn't really explain vision phenomena like after images or color blindness. Like, why is it some people can't see the color green? My grandfather, for example, could not see the difference between the color green and the color blue. He would have to have all of his paints labeled, and then my grandmother would go in. He was a carpenter, so he did a lot of woodwork. My grandmother would go in and pull out all the pots of paints. He would tell her, I want these colors, and she'd go in and pull them out and say, use this one, then this one, then this one, and that's how he would paint, because otherwise he had no idea what he was actually pulling out. So there you go, little family history for you. So we go to Edward Herring's opponent process theory, and this gets a little more complicated here. His idea is that our sensory receptors come in pairs. So we may have blue and green, or we may have red and yellow. So we have this chromatic system, and of course our rods are black and white. And so the idea is that when we put these together, get those to come up here, when one color is stimulated, so like if we see red, the other color is inhibited, like green. But what'll happen is if the red is firing a lot, then when it quits firing, so we look away like at a wall or something, the green one will fire, and it's almost like, hey, you just rest, I got this, okay? And the green one's kind of like letting the red one cool down. It's firing to kind of help the red one cool down. So this is why they think the idea of an after image comes from. Or color blindness, perhaps there's a part of the sensory receptors that aren't working the way they're supposed to. So it's a more complicated system, like if I see something, it's going to stimulate either my red or my green, but at the same time, it does allow us to understand visual phenomena better. All right, question 12, Gestalt psychology, also called Gestalt laws, the laws of perceptual organization. So we want to look at these four parts here. If I am talking about Gestalt psychology, Oh, hold on, click. There we go. So the idea is, what am I talking about here? And what I'm looking at is how I organize and perceive my world. So for example, when I walk into a room, I don't have to stop and identify every part of that room, right? I just take it in as a whole, and my brain says, oh, you're in the living room. Oh, you're in your bedroom. You're wherever. So Gestalt psychology is kind of interesting in that it's looking at how do we organize all of this sensory information coming at us, and how do we put it together. And so the idea in Gestalt psychology is that the whole is greater than the sum of the parts. So let's talk a little bit here about figure and ground. Figure and ground says that I tend to see the main objects of wherever I am before I see my surrounding environment. So some people tell me they see the barn first, or the horses first, or maybe the mountains first. But I've never had anybody tell me they see the trees, or they see the fence, or they see the other mountains in the background. Or I think one time one of my students found a cell phone tower like right there. That stuff's all peripheral. With figure and ground, we're drawn to kind of the main area first, and then we look at what else is going on around it. Good figure. Sometimes we have more than one stimulus coming at us at the same time. If that happens, according to good figure, we're going to see the strongest stimulus for us first. So for example, at this picture, you may see two Batmen. Whoops, sorry, back up. Or you may see Wolverine. If you're a fan of comic books there. In this picture we talked about, what do you see? Do you see the candlestick, or do you see the two faces, or the vase, or whatever we decided that was? Um, and that's what good figure says, is whichever one is a stronger stimulus for you, you're going to see it first. For example, perhaps you notice black before white. Maybe black is a stronger stimulus for you than white. Perhaps you see faces over anything else. Perhaps faces are the strongest stimulus. Closure and proximity. I love this picture right here. What do you see when you look at it? Well, most of my friends said, I see a dog. And I said, really? Do you? And they looked at it and said, no, wait, I see lots and lots of blobs. There's one here, and there's one here, and there's one here. Closure is the idea that our brains fill in the gaps. They'll fill in whatever is not showing, and they will allow us to perceive the information. It's why if you see a sign and it says O-E-N, you know it means open, even though you didn't see the P, because your brain filled in that P and said, hey, it's open. And then proximity has to do with the location of items, how close they are to something, as to how we see it. So in this case, there's 6 lines, but you might actually see 3 skinny stripes and 2 fat rectangles because of how close those lines are to each other. All right, my friends, we are rocking and rolling here. We're looking at some dream theories. I know we didn't talk about this a lot in class, but dream theories are kind of interesting. Why do we dream? As we know, we still aren't sure why we dream, but there's several leading theories that seem to explain parts of why we dream. We're still working on the full unified theory. The first ones is Freud's wish fulfillment. Sometimes we have dreams that maybe we would never do in real life, but we do in the dream. And Freud said that dreams are a way for us to have a psychic safety valve. We might have something that's hidden inside of us that we want to express, but we're afraid to for various reasons. It might be unacceptable. It might be scary to us. And so he says that with dreams, we have the manifest, the part that we actually see in our dream, but we also have the latent content, which is the hidden meaning. And if you remember, I had Herbie riding a motorcycle, hugging an alligator, and I said, why might he be having this dream? Because obviously he does not want to hug an alligator or driving a motorcycle with an alligator, neither of which sounds like a good idea. And so the idea with wish fulfillment is you might need to see not what's the manifest content, the motorcycle and the alligator, but what's the latent content? What could be the hidden meaning? And some people were talking about how maybe the alligator represents something Herbie's afraid of, but if he doesn't conquer it or lets go of it, then his life will spin out of control, and the bike kind of represented his life. Information processing, the idea that dreams just help us sort out the day's events and kind of build memories and put them in the right place. But then sometimes we'll dream about things we haven't experienced, so doesn't necessarily go with this. Some people say dreams are just physiological functioning. It means that our brain is just kind of preserving neural pathways and putting together the convolutions and sort of tucking things in where they go, which could be true, but how come our dreams sometimes have meaning? That's where physiological function falls apart. And then activation synthesis basically says that our brains don't like to be bored. So while we're sleeping, our brains just amuse themselves by throwing lots of pictures out. And then because we like patterns, we're like, oh, there must be a story there. So we try to put it together. And then cognitive theory, the idea that our brains, our dreams reflect our cognitive development, our understanding and our knowledge. That's why children maybe have, more simple dreams or maybe more fun dreams than we do as adults. All right, number 14, we're getting into classical conditioning, the different parts and some terms from classical conditioning. All right, the unconditioned. Remember, the term unconditioned refers to unlearned, meaning things that no one taught us to react to. So an unconditioned stimulus is the stimulus that we respond to that we were never taught to respond to. In the case of baby Albert, John Watson played a loud noise. That was the unconditioned stimulus. No one taught baby Albert how to react. The unconditioned response is the behavior that happens naturally as a result of the unconditioned stimulus. In that case, poor baby Albert cried, right? The neutral stimulus is always presented with the unconditioned stimulus, and it's one that's not necessarily initially connected to it, but it will be over time. So in the case of baby Albert, it was the white rat. The conditioned response is the behavior that's learned as a result of the exposure to the unconditioned stimulus, and the conditioned stimulus is the one that is connected to the conditioned response. So the white rat, over time being paired with that unconditioned stimulus of the loud noise, becomes the conditioned stimulus, and the conditioned response for baby Albert became crying at the sight of the rat. All right, my friends, we are doing awesome. Keep it up here. Some other terms to remember: acquisition. How long does it take the person or the animal to learn the association? So for example, how long did it take the dogs to associate the food with the bell? Remember Pavlov's experiment where he rang a bell and the dogs were like, eh, and then he showed them food and the dogs were like salivating because they were hungry. And every time he gave them food, he rang the bell. And over time, the dogs would salivate at the sight of the bell. Generalization has to do with responding to a similar stimuli. So we think about baby Albert responded to anything white, white beards, white cats, white rats. He couldn't distinguish between them. If it was white and fuzzy, he became afraid of it, just like he would with the white rat in the experiment. Discrimination is when you can tell the difference between similar stimuli. So a child maybe is afraid of a wolf but friendly towards a dog, or the child begins to realize that dogs and cats are not the same thing, and that's a kitty and that's a doggy. And then last but not least, extinction. Over time, if you have been exposed to an unconditioned stimulus being paired with a conditioned stimulus, but you see that conditioned stimulus and you don't continue to experience the unconditioned stimulus, you will break the association. So for example, if the dog hears the bell but doesn't get food, over time the dog will stop salivating when he hears the bell and he'll go back to Of course, he can recall that very, very quickly thanks to our friend's spontaneous recovery, which is where an extinguished response can be revived if you pair the unconditioned stimulus with the conditioned stimulus. All right, my friends, we are doing awesome, getting there here. Questions 16 and 17. 16, what is operant conditioning? We want to talk about positive and negative and how it's used. And what is shaping? Okay, operant conditioning has to do with voluntary actions, operants, things that we choose to do that can have an effect on our environment, and then we see the consequence. Positive, remember, means applying a, applying a stimulus, and negative means withholding a stimulus. Sorry, guys. It's a lot to go through. My brain starts to shut down after a bit. Positive, so for example, a positive reinforcement means that you are giving something, you're applying a stimulus to encourage behavior. A negative reinforcement means you're withholding a stimulus to encourage, the behavior you want. Punishment, same way. A positive punishment means you're applying a stimulus to decrease a behavior you don't want. A negative punishment meaning that you are withholding a stimulus to decrease behavior you don't want. I know that sounds weird, a positive punishment, but remember, in operant conditioning, positive and negative don't mean what we think of in regular life, good or bad. They actually refer to whether or not you apply a stimulus. All right, shaping. Let's say you've got a child who you want to learn a new behavior. Let's say this child is, I don't know, 7, 8 years old, and you want him to put away his laundry. Well, chances are, if this is his first time putting away his laundry, you're not going to be like, here's the basket, good luck, honey, go put it away. Because more than likely, you're going to walk into the room, and the kid's either going to be sitting there staring at the basket, or the basket's going to be all over the floor, and the drawers are going to be a mess, and you're going to be very, very sorry. So with shaping, you're going to reward the child for getting closer and closer to the desired behavior until eventually he gets to that desired behavior. So in this case, rather than saying to the child, hey, here's your laundry, good luck, you're going to say, okay, your job every time I do the laundry is to take your basket to your room. Okay? If your child takes the basket to the room, you give some kind of positive reinforcement to continue encouraging that behavior. Once the child's pretty comfortable with that, you might say, okay, now your job is to put everything that goes in here, all the jeans and t-shirts, into this drawer. So your job is to take out the jeans and t-shirts and put them in. So now he has to take his laundry basket to his room and put away his jeans and t-shirt. Again, this is positive reinforcement. You're no longer reinforcing for taking the basket because that is routine. He's already mastered that activity. So you're going to continue doing this. Okay, now you're going to put away the jeans, the t-shirts, and you're in this drawer, you're going to put away the underwear. And so each time he adds that other step, over time, you're going to add more reinforcement. But then when you add a new step, to get the reinforcement, he has to go all the way to the new step. And eventually, he'll be comfortably putting away his own laundry. And that is shaping. Instead of just saying, good luck, hope you get it, it's actually getting them closer and closer to your target behavior through successive approximations. All right, we are getting there, my friends. Albert Bandura, his theory and how he believed children could learn, and the Bobo doll experiment. So much fun. Social cognitive behaviorism. Albert Bandura was the gentleman who created the social cognitive theory, also known as the social learning or observational theories. Has different names, but essentially it's kind of referred to now as the social cognitive theory. And he said basically that humans can learn by observing and modeling others, especially if they identify with that person. And so this behaviorism is a little different from classical and operant conditioning in that it does incorporate some cognitive factors like your belief systems, your self-perceptions, expectations. So it's still external, but it's got a little bit of internal going on with it. So the question that I had my students think about is, do you think observing violence on TV, movies, and video games leads children to behave aggressively? And that question I brought up because that's the question that Albert Bandura was trying to resolve. And here's a Bobo doll for you. The Bobo doll's name is Bozo. Try saying that 5 times fast. And so this was a question because in the 1960s, people believed that if children watched a TV show that was violent, they would release their violent urges because they'd see it on TV and it would be cathartic for them because, oh, okay, that person was violent. Now I don't have to be violent. But the question is that true? That's what Bandura was kind of trying to find out. So as I said, this was a hot question in 1961. And he created a study where he had this Bobo doll where if you knock it down, it gets back up. And he invited children ages 3 to 6 years who were enrolled in the Stanford experiment. Actually, he invited their parents to allow him to use these children. Unlike John Watson, it was completely and fully informed consent. The parents were told exactly what was going to happen and how it was going to happen. And so he would put an adult in a room in front of the children, and they matched levels of aggression. They had boys and girls in each group. I mean, they tried to match things like that that could affect the experiment. So sometimes a boy might be watching a woman, sometimes a girl might be watching a man, or sometimes they'd be watching someone of the same sex. And they would have the adult either behave really aggressively, beating up this Bobo doll, or maybe just gently pushing it and playing with it. And they wanted to see what would happen if the child observed an adult. Sorry, we don't get to watch it. But what they found out was the child was more likely to imitate the behavior, whether they watched the adult live, or then later he did the same experiment with the children watching the adult on TV. They even had the adult dress as a cat. And it still showed that children were more likely to behave in an aggressive manner if they watched the adult behave aggressively, especially if the adult was the same gender that they were, which indicates that if kids are watching violence on TV, Bandura is finding that that would be likely to cause them to behave more aggressively. And as you can see, it showed that they even continued after the experiment. And they predicted that the children in the non-aggressive group would be less aggressive, and they also predicted boys would be more aggressive than girls. And they found that both of those predictions were correct. All right, my friends, it's time to take your interim assessment, or it will be soon enough. It'll be due by Monday, October 15th. It says 10 o'clock a.m. I'm not 100% sure on that time. I think they may have changed it, but basically if you can get it done by Sunday, October 14th, you're in good shape. Some of you will be taking it in class with me. I'll be inviting you. Some of you will be taking it on your own. I believe the first group to take it in class will be October 4th, and then the other group will be Tuesday, October 9th. And here is a list of assignments that we've completed. I've marked test 105 and test 207 in red so that you remember you have to do those to get to the interim assessment. But make sure that you are caught up on this. Good luck on your test. You are going to do great, just like Tony the Tiger would say. And thank you guys. I know this is a long video, but I hope that you find it really useful. So let me know if you have any questions.